Today we're going to talk about the multi-level feedback queue. Basically, multi-level feedback queue is like the multi-level queue, but the difference is the processes can move between the queues. In this case, we'll use the multi-level feedback queue with 3 levels, where Q1 and Q2 follows the round-robin scheduling algorithm and the Q3 follows the first come first serve. First, I'm going to answer the first 3 processes in our first set of data, and then we'll test this out to our C program that uses the multi-level feedback queue scheduling algorithm. Then I'm going to fill out the rest of the table and Gantt chart of CAM. The first process that arrived is process 1 at time 0. So we'll put time 0 here, and then we'll put process 1 here, and in the above also to check and to track them. And then for this first process, this has a burst time of 1 milliseconds, and their Q1 has 3 milliseconds. Basically, what we'll do is just add 1 here because it has a burst time of 1, and then we'll put OK here, so that will mean that it completed its process in the Q1. And then we have the process 9 here, this one, which arrived at time 1. So we'll put process 9 here, and then process 9 in the above. So this process 9 has a burst time of 3, and our Q1 is 3 milliseconds, so we'll just add 3 here, so that will be 4, and then we'll put OK here because it finished its burst time in the Q1. So the next one is process 2 here, which has a burst time of 15 milliseconds, so we'll put process 2 here, and then process 2 in the above. Since the burst time of the process 2 is greater than our time quantum here in Q1, we'll just subtract the quantum time 3 milliseconds from 15. So that will leave us 12 milliseconds remaining time. In multi-level feedback queue, when our process has not yet completed its execution, or like if it has a remaining time left, it will move to the next queue. So process 2 here. If you subtract the quantum time of Q2 from our remaining time in process 2, that will leave us 7. So we'll have 7 more left. Since process 2 has not completed its execution in Q2, this will move to the next queue, which is the Q3, which follows the first come first serve. So in Q3, process 2 will finish its execution finally. Basically, that's how multi-level feedback queue works. I'm going to fill out the rest of the table and the Gantt chart of CAM. As you can see, I have filled out everything in here, the table and the Gantt chart, and you'll see that this one is like mixed up because this table is sorted by their arrival time, so it will be easier for us to fill out the table and the Gantt chart. In this column, we'll see the process ID, and then the arrival time, the burst time, and I have filled this out by their completion time here. And then turnaround time is just completion time minus the arrival time. And then the waiting time is turnaround time minus burst time. I also put the average turnaround time and the average waiting time. So that will be 271 divided by 10 because we have 10 processes. So that will be 27.10 milliseconds and then 21.70 milliseconds for the waiting time. Now we'll move to our C program that uses multi-level feedback queue scheduling algorithm. This program requires the user to maximize the window to full screen. So we'll press any key to continue. This program has 3 levels. The level 1 is round robin algorithm, and the level 2 also, and then the level 3 follows the first come first serve algorithm. So first it will ask us to put how many processes. So we have 10 processes. And then we'll put the arrival time and the burst time. So 1, 15, 3, 7, 4, 3, 5, 4, 7, 5, 6, 4, 9, 6, 1, 3, and then 10, 6. And it will ask us for the quantum time of Q1, which is 3, and then for the Q2. It says here in the program that the table is arranged according to the completion time of the processes. So this one, as you can see. If you compare this program to our Excel file earlier, our first set of data, it is identical. The average turnaround time is also 27.10 milliseconds and the waiting time is 21.70 milliseconds. So we'll check the Gantt chart. So this looks the same with all the processes and also the time. It also displays what queue is the process in. From process 1 to process 10, that's the Q1, and then the process 2 to process 10, that's the Q2, and then this one is the Q3.
Luis Angelo Gomez from BSIT 2A. Today we're going to talk about a set of data composed of processes. So as you can see on the screen, we have process ID, arrival time, and burst time. So the first process has an arrival time of 0 and has a burst time of 3. Second process has the arrival time of 5 and the burst time of 12. And the third process has a arrival time of 7 and a burst time of 5. And the fourth process, or the last process, has an arrival time of 5 and has a burst time of 10.
So today's sets of data is composed of 4 processes which have the process 1 arrival time of 0, the burst time is 3. Process 2 have the arrival time of 5 and the burst time of 12, and so on. So the goal is to find the average turnaround time and waiting time. So to find the average of the two, first we need to find the completion time. And to find the completion time, we first need to compose an Gantt chart. So to compose an Gantt chart, we will find the lowest arrival time, which is the process 1. So yung process 1 natin nag-arrive sa 0, so ilalagay natin siya sa Q1, sa ready queue ng queue level 1. So dito, and 0 tong time ng CPU. So dito nag-arrive yung process 1 at i-execute na natin siya, which is ang level 1 ay mayroong 3 na quantum time ng 3 milliseconds. So ang level 1 ay kaya lang i-execute ay 3 na milliseconds. Ang burst time ng process 1 ay 3. So kayang-kaya niyang i-execute ng kompleto tong process 1. So 0 hanggang 3 ang process 1. So complete na, wala nang remaining time ang process 1. So sa process 2 na tayo, which is nag-arrive sa 5. So dito ilalagay natin yung time ng CPU, 5 milliseconds. So itong 3 to 5 na to is idle siya, kasi walang process na nagaganap diyan. So dito ilalagay na natin yung process 2 sa ready queue ng level 1. So ang burst time ng process 2 ay 3. Ang quantum time lang ng level 1 is 3. So ima-minus lang natin siya. 12 minus 3 is equals to 9. So ang remaining time pa ng process 2 ay 9. So ilalagay na natin siya dito. Nakompleto na niya ang 3 na time sa process 2. So 5 to 8. So itong 5 to 8 na to, nag-execute din yung process 2 pero hindi pa siya kompleto. So pag hindi pa kompleto, ilalagay natin siya sa level 2. Ilalagay natin siya sa ready queue ng level 2. So dito pupunta ang P2. So pag tinuloy-tuloy nyo lang to hanggang ma-kompleto nyo ang chart, magiging ganito siya. So to find the completion time, hahanapin natin kung saang milliseconds natapos ang bawat proseso. So, sa process 1, natapos ang process 1 sa 3. Ang process 2 natapos sa 8. Ang process 3 natapos sa 25. At process 4 natapos sa 32. So, nakuha na natin yung completion time, makukuha na natin yung turnaround time. Ima-minus lang natin tong completion time at arrival time. Sa waiting time naman, ima-minus natin ang turnaround time sa burst time. So, pag na-minus na natin siya, magiging ganito na siya at kukunin natin yung average ng process 1 to process 4, which is magiging itong dalawa. So, ang average turnaround time ng apat na proseso ay 15.75 milliseconds and yung average waiting time is 8.25. So, i-check na natin siya sa program natin. Ito ang program natin, which is please enter NAQ to continue. So, hinahanap ang number of processes na i-execute. Is yung process natin 4. So, enter natin 4. And ang process 1 may arrival time daw na 0 and ang burst time na 3. So, enter natin 0 and 3. So, hinahanap lang yung arrival time and burst time ng bawat process. So, enter lang natin yung mga arrival time and burst time. Ayan, and 5. Ayan, last 8 and 10. 8 and 10. So, hinahanap naman ngayon yung milliseconds ng quantum time ng level 1, which is 3. Sa level 2 is 9. So, 3. Sa level 2, 9. So, ito na yung complete table and chart. So, check natin kung tama ba siya. So, sa process 1, may completion time siyang 3, turnaround time 3, and waiting time is 0. So, sa process 1, may completion time na 3, turnaround time 3, and 0. So, to check natin siya kung tama ba talaga. Sa 2 naman, check natin. 23, 18, and 6. 20, process 2, 23, 18, and 6. So, tama itong lahat. So, next, check natin yung average turnaround time and waiting time, which is 15.75. 15.75. Sa waiting time natin is 8.25. And 8.25, tama tayo. Sa chart naman tayo, yung complete Gantt chart. Ito, check natin siya kung tama ba siya. Is yung sa process 1 is 0 to 3. Process 1, 0 to 3. Sa process 2, idle siya. Ay, sa 3 to 5, idle siya. So, tama tayo. And process 4 is 5 to 8. Ay, process 2 is 5 to 8. So, tama tayo. Hanggang 32. So, tama tayo dyan. So, yun lang ang MLQF algorithm. Sana may natutunan kayo and thank you sa pakikinig.
Hello, I am Earl Darren Azores, an IT student from Technological University of the Philippines. Today, I will show you a set of data and I will use it to show you how MLQF algorithm works. Now, let's move on.
So today's sets of data composed of 10 processes, which have the process 1 have 0 arrival time and burst time of 6. Process 2 have the arrival time of 2 and burst time of 3, and so on. And our quantum time of each level have a 5 milliseconds in level 1, 7 milliseconds in level 2, and 5 po algorithm in level 3. So, our goal is to find the average turnaround time and waiting time. To find the average of the two, we need to find first the completion time of 10 processes. So, para makuha natin yung completion time ng mga processes is lalagay natin siya sa chart para mas mapadali tayong makuha yung completion time. So, hanapin muna natin yung pinakamababang arrival time sa 10 proseso, which is the process 1. So, yung process 1 nag-arrive sa 0. So, 0. Ilalagay natin siya sa queue. sa nakapila yung sa 0. So, ang quantum time ng level 1 is 5. So, kada process, kaya lang niyang i-execute ay 5 milliseconds lang sa level 1. Ang burst time ng process 1 is 6. So, may matitira siyang 1 kasi hindi kaya ng 5 milliseconds yun. So, 1. So, ilalagay natin ang process 1 dito hanggang 0 to 5. So, yung natirang oras na to is i-execute na yan sa level 2. So, ilalagay na natin yung process 1 sa level 2, sa ready queue ng level 2. So, para ma-execute na yan sa level 2. Kasi bawal na siyang i-execute dito sa level 1 kasi dumating na siya dito. Na-execute na siya dito. So, next is the second lowest of the arrival time, which is process 2. Nag-arrive sa 2. So, habang na-execute tong process 1, marami nang nag-arrive na ibang proseso, which is 2, 3, 4, and 5. So, 4 na process, which is process 2 to 5. So, ilalagay natin siya sa ready queue ng level 1. So, yan. Ang uunahin natin i-execute itong process 2 kasi siya yung nauna, which have the burst time of 3. So, kaabot ng quantum time ng level 1 ang burst time ng 3. So, ma-execute na siya ng kumpleto. So, wala siyang matitirang remaining time. Wala siyang matitirang time. So, complete na ang process 2, which is 5 to 8. So, andito ang process 2. So, pag tinuloy-tuloy nyo lang yung proseso ng ganito, dapat makukuha yung result ay ganito. Ganitong chart. So, para nakuha na natin yung chart, makukuha na natin ngayon yung completion time ng mas madali. So, sa process 1, makikita natin na kompleto siya sa 48. So, 48 ang completion time ng process 2. Sa process 1. Sa process 2 naman, hahanapin natin yung isang na kompleto, which is 8. And so on. So, pag nakuha na natin yung lahat ng completion time, para makuha na natin itong turnaround time and waiting time, i-minus natin yung turnaround time, i-minus natin yung completion time at arrival time para makuha yung turnaround time. Sa waiting time naman, para makuha natin to, ang i-minus natin ay turnaround time at burst time. So, para makompleto itong table, dapat magiging ganito ang result nyo. Yan. Ito ang result. So, pag nakuha na natin yung turnaround time, makukuha na natin yung average nila, which is 46.50. 46.50 and the waiting time is 38.50. So, para ma-check natin siya kung tama, i-input natin siya sa program na ginawa. So, ito yung program natin. So, press Enter to continue. So, ina-ask kung ilan daw yung processes na i-execute natin. So, yung processes natin ay 10. 10, enter natin 10, and hinahanap yung arrival time ng process 1, which is 0. And the burst time of 6. So, hinahanap yung arrival time and burst time ng mga proseso. So, enter natin siya lahat. 2 and 3. 3 and 8. 3 and 8. 4 and 5. 4 and 5. 5 and 15. 5 and 15. 6 and 7. 6 and 7. 7 and 9. 7 and 9. 8. 8 and 10. 8 and 10. 9. Process 9 is 9 and 4. 9 and 4. Last 10 and 13. 10 and 13. So, next naman ang hinahanap yung quantum time ng dalawang level. So, sa process 1 sa level 1 is 5. Sa level 2 is 7. So, enter natin. 5 and 7. So, ito yung complete chart. So, check natin kung tama ba siya. Hanapin natin yung process 1. Itong 1. Ito yung process 1 which have the completion time of 48, turnaround time of 48, then the waiting time of 42. So, 48, 48, 48, 48, and 42. So, tama tayo. Next naman natin i-check yung average turnaround time and waiting time, which is the average turnaround time have a 46.50 milliseconds. So, 46.50 milliseconds. So, correct tayo. So, we no need to check all of this, all of the turnaround time, because tama na tayo sa sa average. Next naman is yung waiting time, which is 38.50. 38.50. So, correct na naman tayo. Next na i-check natin is yung Gantt chart. Ito yung Gantt chart ng program. Ito ang Gantt chart ng ginawa natin. Ito ang Gantt chart. Medyo mahaba. So, the process 1, 0 to 5. Process 1, 0 to 5. Tama tayo. Process 2 is 5 to 8. Process 2 is 5 to 8. So, tama na naman tayo. And so on. Hanggang 80. Hanggang 80 ang process 10. So, tama na tayo sa chart. So, yun lang. Sana may natutunan tayo sa MLQF algorithm. At salamat sa pag-init.